First up is I showed off last Friday, the deep linking, and we talked about the highlighting not being very apparent. So uh, I made an adjustment to the animation. Let me pull up a long thread. And Darren recommended a Stack Overflow link that had kind of like a yellow fading animation, and I just shamelessly copied that because it looks good. So now we got that too. And I think it's more apparent and it goes away, so it doesn't stay on the screen for too long. So it's annoying to the users. All right, next up is a fix that I just deployed to dev a few minutes ago. So it's not yet on production, but it will be after this meeting. But I want to show it off anyway. Finn from the alpha testers channel flagged that he was trying to format a response like basically this format, but with some users or domains. And basically, when there's text that has no spaces in between, the browser doesn't automatically wrap it to the new line, and that's the bug that it looks bad. So, and this is on dev right now. Yeah, it's just a fix of that. The browser will actually wrap long text, even though it doesn't have any white space in it, no spaces or hyphens or anything like that. And we should I'll let Finn know once it's on production that is fixed.
Thank
I think this would also be an issue with super long links, which I guess no one has gotten yet, but this should solve that too whenever that happens. Got two small ones, and I'm going to show screenshots of how they looked before because I have them prepared here. So the first one is the sign up button was under the upload button, and now it's not. It's all good. So you can sign out peacefully. That's the first one, small fix. And the second one is in the knowledge panel, some types of files. This one is a PowerPoint. I misjudged exactly how we were getting the data. So this is just like some long text that was also overlapping the name. And the after is that all file types should now be better because now I use the file extension of the file instead of the file type. So it should be good now for all of the files, unless they have a really long file extension, but I've never seen one longer than 5-6 characters.
Yeah.
Okay, next up is the big one, and I'm going to show off what's in production right now, and I'm also want to show off something that I'm working on and request feedback on it. So first, let's start with what's right now in production regarding the knowledge tab panel. So last time when I showed it off on Friday, it was not connected to the backend and not really working. It was mostly just the UI with the table. There's been a few changes. So now one thing I want to highlight is that there's a knowledge sub item under the active tab. So whenever you open a tab, there's also like a knowledge sub item, I guess is a good name for it. Clicking on it will take you to the knowledge tab. So right now it's highlighted in two places, here and here, that you're on the knowledge for this particular thread. And this thread stays like colored, so you know it's kind of active, but it's also not the main thing because the knowledge is the main thing that's active right here. And different from last time is that there's now two sections. One is for the knowledge that is powering this thread, similar to how it is on the sidebar. And there's a section for the knowledge that's not powering the thread. And you can search through both of them. Let me search for CSV maybe. Or you can search through their names, or if you type in the search box, basically what it's gonna look through is the name that we generated the original file name and the summary right now.
Just a question on the type, the casing here. Is
Yeah.
this, do we want to capitalize or should it be sentence case? I guess question
Well,
for Erica.
before Erica answers, we're actually gonna change the text, I think, based on some feedback from the office hours.
Okay.
So it's not going to look like this. And I'll show
Mm.
that off in a minute. You can sort these independently. Let me find one with two. Okay, I'll just add some. So you can sort these two tables independently. So for example, this one I can sort by name, and this one I can sort by summary or by file type. They're the same type or less updated, and they'll be independently sorted. You can also add or remove files just like in the sidebar. From here, you can upload knowledge, or you can click on this smart chat with this knowledge. This is kind of a way to link this section here that it powers the smart chat, and clicking on it will just take you back to the smart chat tab. So that's what's in production right now. And I am working on some new changes and it's not yet finalized, but I just want to show it for feedback. And the biggest request, and this is coming from Drodio based on the office hours, I believe, is that there's more of a distinction between the knowledge tab when you're going to like all your project knowledge, and the knowledge section for a particular thread. So the biggest thing that I've changed is clicking on the knowledge for a thread should pop out a kind of like a modal side panel thing that overlays the smart chat, but is still like part of the thread conceptually. So it's a bit more clear that you're operating in a thread basically when you're here.
Also, when Aaron gets the multi-file working, the way that files work in threads is going to be very different. So if it's not quite right yet, because I think we're not exactly displaying reality today. So when you show that
No.
screen where we're showing two files, that's not actually true.
Well, it could be. It depends on how much of the context window each file takes up.
Interesting. Okay, so could you help us understand how to describe what's happening today to a user?
Well, first, let me just confirm that because it's been a while since I looked at that code. But what I believe is happening is that if that first file was just a simple message like "Hello, Aaron," period, right, it would only be 20 tokens or something like that, which should leave plenty of room for the second file to be included in the context window. So there's a fundamental concept that these LLMs work with, which are tokens. And Andy, if you could go back to the thread and click on hover over the GPT-4o. And so here we can see that we answered with 4.0 and we consumed 163 tokens in this message. Now it's difficult to know exactly what a token size is. There's an algorithm at work that Apple may be 2 tokens or it may be 1 token. And, I don't know off the top of my head why it decides that some words are 2 tokens and some words are not. But maybe an easy way to think of it is syllables. That's what I try to do it in my head anyways, is say if it's a multi-syllable word, chances are it might be 2 tokens. And so a word like date is certainly going to be 1 token, but eld might be a token, could be a token, and then berry could be a token. And so the way that the LLMs actually work is they don't know what they're doing, right? These are amazing machines. What a development. They really have no clue what they're doing. All they do is they try to predict what is going to follow this token. And it was around 2018, my understanding of the story is that the folks over at OpenAI were running a test on their new LLM, and they were trying to match the product reviews that people were posting on web pages And they've got this algorithm down in a way that it was actually matching, you know, character for character what real people were typing, and that's what unlocked this whole world.
Mhm.
And so all they do is they try to apply the context to figure out, you know, is this going to be an X after this, or is it going to be, you know, so they work in the concept of a token. And so they're not really predicting the next character, but they're predicting a chunk of characters or a token. So if it was def, then it might think that this was the word definitely and, you know, make that its prediction that it went with. And so all of the LMs have different context windows. And what that means is that you know, they're considering the prompt, they're considering how much of the data that we've put in here. And once their context window is full, if you imagine like a cup of water, there are a couple of ways to deal with it. If we send too many tokens, we'll get an error. Like we saw this in dev last week with Mike, where he got a 2 million token error because the Excel file that was processed overflowed the bucket, and Gemini just says, no, you can't use this. I think what happens in Smart Chat today is we just truncate it. And so if we've got too many tokens in the bucket that we're sending over to ChatGPT, we just overflow and we don't warn the user that we've overflowed, and we only partially send data. And we do the same thing in Gen 2. So if this file was 50,000 tokens, and if my memory serves right, GPT-4o only allows 38,000 tokens, which includes the prompt, and it includes however much text we are providing. We basically put as much, we prioritize first the prompt. So the prompt is always going to get sent. But then we have a budget of remaining tokens. And if this prompt, let's just, to keep the math easy, let's say it was 1,000 tokens, then we have 37,000 tokens available in our budget. And so we will pull from this file up to 37,000 tokens. And then now we've sent the file and we've set the prompt. And then so if we have more space available, we'll go ahead and burn that budget on the next file that is available to us. And so there are three things that are burning this budget. One is the prompt, and the most recent prompt is always prioritized. Then there's the files that we're sending, and then there's the chat history. And so we're and there's a little bit of a balance here. I don't remember exactly how I did it, but if I remember right, I'm trying to make sure that there's some context from the previous messages here, as well as you know, the data that you're trying to chat with. Because it would be a poor experience if like the LLM forgot about the last message that you sent it. And so I think what I did there is I tried to make sure that it was like 1 to 3 of your original, your first messages. Let's say that you had 20 messages here, that I would prioritize the first 1 to 3 messages that you sent, and then I would skip over things in the middle, and then I would go back and try to grab maybe the last 3 messages, so that my theory there was that this kind of established the mission and the purpose that you were embarking upon, and then if we didn't remember the last message or two, that it would just feel really silly and stupid.
Yeah.
And so anyways, there's this balance, all trying to make sure that we don't send too many tokens to get an error, and just enough to sound intelligent and make the system smart for you. And so if this file has only 10 tokens in it, because it's just a small text file, there should be plenty of room for this file to have some of its data included in the budget.
Aaron, I added this. I don't know if you want to talk about it at all. It's kind of an
Yeah, I
invisible
can
thing
talk.
happening. Sure.
Yeah, can you go back to the other screen? And so what the side quest that I've taken upon myself is started really from the bugs. When I looked through the bugs, we had 60 bugs. Jordio asked us to look at them. And after I looked through them, it was very clear that a huge portion of them were related to file uploads, either getting hung or, you know, various issues. And so I've tried to reorganize those bugs a little bit. I created like a super bug ticket that I made the parent of some of these other bug tickets. And as I've been changing the architecture slightly of the way that we have our file processing service and our control plane service. And so what that means is that there's a UI that we're looking at here, and that UI makes API calls to what we call a control plane. And so when we have an active thread like this, there's a WebSocket connection, and then sometimes we'll make an HTTP connection. And the WebSocket connection is messages are going back and forth. And so when you upload a file, what happens is we make an HTTP request to get a secure link so that we can upload the file to Google Cloud Storage, which is encrypted, and we can save the file. And then what happens is the UI will start sending all those bits of the file over to Google Cloud Storage until the entire file is now over here on Google Cloud Storage. And then what happened is the control plane would it would get a message back from the client that says, okay, that file's over there, you can work with it now. And then the control plane would send a message through a queue, a background queue, and then it would start, there could be many files that are in that queue. And so that file would go to the top of the queue, and then we would slowly drain that queue, and we would process that queue to get the summary, get the keywords, etc. And in order to provide this little status update over here that you've all seen, extracting or summarizing or whatever the text is, the UI, so this process over here that's working the queue, what it would end up doing is saving and updating the database record to say summarizing. And then once it was, or extracted or whatever, it would post updates here. And then what was happening here is over the WebSocket server, the control plane was polling once a second to say, hey, what's the current status here? And then get that, bring it all the way to the UX so that we could show down here that it was extracting or summarizing or transcribing or whatever it was doing. And I'm going to keep all of this architecture, but that architecture is going to be used only for the kind of background processing in integrations. And so one way that the UI might use it is if you go to the knowledge tab and you're not actually working in a thread and you upload a file and it's not going to go in a thread, and we don't have this capability now, but at some point I'm sure users will just want to upload a zip file or just upload knowledge and chat later. The system that I've just shown will be the way that continues to work, which is a very resilient system. It might, if we're processing a whole bunch of assets, it might take a little while for your file to get processed, but it will get processed and it'll be retried and all of that. And so all of this will still stick around. But the changes that I'm making here are that when the UI uploads the file over to Google Cloud Storage, and it tells the control plane that, hey, that file's there, you can go work on it. Now that drop zone component that Andy pulled up where you can upload your file, it will become aware of, am I inside a thread or am I just like a user who's uploading knowledge to their project? And when it's inside a thread, things are going to behave slightly differently. What's going to happen now is that instead of this kind of asynchronous resilient architecture, it will still be reliable, but it won't be, it'll be more synchronous, if you will. And so as soon as we get that message, what will happen is we're going to go to this file processing service and we're going to keep an HTTP connection open. And as we extract the text and process the text and do all these things, these updates are going to be streamed back to the UI, and they'll just come right back along through the WebSocket method, right back into the UI to power here. And what that means is like the fastest we can get an update in this current system is once a second because we're pulling. And because every one of these status updates required a write to the database, I was very selective in the updates that I would put there. And so now in this mode, the system will be enhanced, and we're going to know that there is a user waiting on this file to chat with it immediately. They're not just contributing new knowledge, they want to work with it now. And so in that mode, the system is going to have much higher resolution and fidelity on these status updates. And so uh, also, and I'll go ahead and share my screen now. Let me get this going. And so also what will end up happening is hopefully is the font okay, or actually let me bump it up. Presentation mode. There we go. Compute steps. The test case should be a good example. So whenever we process a file now, this file processing service is first going to compute a plan. And it's going to look at all the parameters, the type of files, which strategies we want to use to extract the text and tokenize it and all these things. And it will then produce a plan. And that plan will say, here are the series of steps that I want to, that I will use to work this job. And once we've created that plan and we've calculated the steps, and this is again an example from the test case, we're then going to dynamically figure out what percentage each step is of the progress bar. And so in this test example, here's a weight of 1, and then if we come back down here, the sequencing is the same here. So this first job would be worth 0.15% of the progress bar. And so these are all kind of tiny little increments. But then when we get to something like this, because some of these steps, we know they're going to be very quick, like just telling you that we have started the worker, or that we've loaded the data from Google Cloud Storage, or that we're starting to extract the content. These are very small updates that should actually happen rather quickly. But as Jordio experienced yesterday or the day before, he was transcribing a call, and it took like 2 minutes to transcribe. And there's no data that I can get from DeepGram to draw a progress bar. And so we fake it until we make it. And so what happens is some of these steps, like extracting content, I've built this in such a way that we'll say, look, this is going to span the next 60 potential progress bar updates. And then what's going to be happening in the background is, you can imagine, once a second, this is going to be ticking to increment from you can imagine that it's going to send this once, and then it's going to send this again, and it's going to send this again. And every time it sends it, it's going to be advancing that progress bar. And so the user, even when I don't have real data to share that Tika is 10% through the file or DeepGram is 10% through the call, the user will still know that we haven't hung, we're still processing the file. And the only downside of this that I can see is that if it doesn't actually take, in this case, 60 spans, a span will tick once every second. And so you can imagine that this could potentially take a minute that the user's waiting for this step to complete. Is that if this happens in 30 seconds instead of 60 seconds, all of a sudden the user will see a giant leap forward to 98% complete, which is not a bad experience for the user, right? It only gets bad when it goes backwards, which is also possible here. And so if we're extracting content, say from Tika, this is our first attempt, and things go wrong. One of my philosophies is you never trust anything, and everything breaks all the time. And so Tika could crash, or have a memory leak, or the database connections are all exhausted, or all these things can happen. And so we're going to retry, and so we will communicate to the user that we are on a retry now, and this is step 2 of 3. Now in this case, what might happen? Let's say that we timed out, and so the user would see this particular update, and their progress bar would be 0.45%. And then we might burn all 60 seconds here, showing them extracting content as the progress bar is advancing towards 98%. And then because we timed out, we didn't complete the job in the amount of time that we gave it. The way the algorithm is working is that you would see that progress bar drain backwards, and we would tell the user that we're retrying now, so they know why the progress went away. It will still be slightly incremented based on the way that I've set the system up here. Now it's 0.6, and if we have to retry again, it would be 0.7. And then it would continue to advance this all the way up to 98%. And then once it's done, the user would see 100%, and the system would say the file's ready. And so that should be a much more pleasant experience. I'm in the act of actually wiring it up to the UI, and so with any luck, I'll actually be able to show a video of this, if not ship it today. And in addition to all this, I've also kind of untangled some of the project so that it is these tasks are all the code was just inside a big function, and so now they're more portable, and the concerns are separated so that a task like deepgram will be able to benefit from this content loader, just like sending something to Tika will benefit from the content loader. And the way that these tasks work is each task kind of creates its own steps. And so this task, the cloud loader task, is specifically where we load the data from the Google Cloud storage server. And it only will emit 2 tasks or 2 status updates, that it is loading and it has loaded the content. And if for some reason it's unable to load the content, it'll just error out, and there's no reason to show a progress bar. And so when something happens like this worker who's processing the text jobs, you can see when it's building its plan, and some of these, like content loader, will choose which content loader to open. So it's possible that this gets 3 progress updates or 10 progress updates. But this is the kind of the sequence that we have to work the job. And each one of these tasks is responsible for reporting on its progress updates. And then so whatever we have to do to process the job based on the type of file and the parameters and all that, it'll end up with potentially a different series of steps that we have to do every single time. And all of those steps will be dynamically calculated so that everybody's progress bar is accurate for the job that we're working. And so in addition to that, something that I'm really liking here is just the error fidelity has gotten much better. And so if the job does fail, I've taken the time to make sure that we have much more granular, unique error reporting. And so as these are all the failure potential spots in processing a file, at least as of right now. And each one of these will get logged out to a Sentry, and then also returned, so that if a user does send feedback, it'll help me very quickly go in and be like, oh, it was an unprocessable error, and that's why the job failed. And so anyways, from a user's perspective, that means that the user is going to get much better mirrors in the elevator lobby soon.